Welcome to Lesson 16, where we finally put real walls around our services. AppArmor is Ubuntu's answer to mandatory access control. Canonical's been shipping it as default since 7.04, while Red Hat went the Linux route. Same goal, very different philosophy. Linux labels every inode with a type. AppArmor just writes path-based rules per profile, and the result is something you can actually read at 3 in the morning. Over the next 20-odd slides, we'll cover the architecture, profile anatomy, complain versus enforce rollout, and auto-generating profiles with aa-genprof, ending with every service on the box sandboxed. So let's ground that architecturally. AppArmor lives as an LSM, a Linux security module, meaning it's a kernel hook sitting right inside the syscall path. When a process calls open on /etc/passwd, the kernel walks VFS, hits security, inode permission, and asks AppArmor a very simple question. Does the profile for this PID's binary allow that path, read? Yes returns OK, no returns excess, and a log line. That's the whole enforcement loop. Verify it's running with systemctl status AppArmor and AA status. On a stock Ubuntu box, you'll see roughly 40-odd profiles loaded, most in enforce, a handful in complain. Now let's open one of those profiles and see what's actually inside. Every profile is just a text file in /etc appamor.d named after the binary's path with slashes turned into dots. So, usr spin nginx becomes usr spin nginx. The structure is 3 layers, includes pulling in reusable abstractions like base and NAS, capability rules granting specific kernel privileges, such as netbin service for binding port 80, and then the meat, path rules with permission flags. Notice R for read, W for write, Mr for mmap execute, K for file locks, and the owner qualifier restricting access to files owned by Nginx's UID. And at the bottom, an explicit deny on home, belt, and suspenders, because in production, paranoia pays. With the profile structure in hand, the next question is how you actually deploy one without breaking production. AppArmor gives you 2 modes, complain, which logs violations but still allows them, and enforce, which actually blocks. The safe rollout is always the same. A complain to start logging, tail the kernel log via journalcdl, or DMES to watch allowed events stream in. Generate real traffic for a week or 2 because synthetic tests always miss edge cases. Then AA enforce to flip the boundary live. Keep AA disable in your back pocket for emergencies. But remember, a disabled profile means an unconfined service. Reload with systemctl or surgically with AppArmor, parser, ER for a single file. Now, handwriting those profile rules from scratch is genuinely tedious work, and nobody does it in production. AppArmor ships 2 interactive helpers that build profiles from real traffic. aa-genprof is what you reach for on a brand new binary. Start the watcher in one terminal, exercise the app in another, then press S to scan. For each file access, syscall, or capability it sees, you answer allow, deny, or glob, and G is the one you'll lean on since it generalizes /, etc. myapp.config.iml into etc. myapp. So you're not reprompted for every sibling file. aa-log-prof is the complement. After a profile has been running in complain mode for days, it reads the audit log and asks you to bless each allowed but unconfirmed access. Same prompts, same muscle memory, and when you're done, the profile is ready to enforce. Once profiles are enforcing, denials become your signal. And they mean 2 very different things. A false positive looks like Nginx being blocked from a log path you forgot to allow. A real attack looks like Nginx trying to read ix, etc. shadow, which is exactly what you see in that first journal output. The triage workflow is straightforward. Pull denials from the kernel log, rank the top offending profiles. High counts usually mean an incomplete profile you'll refine with aa-log-prof, while a sudden spike on a stable profile is your exploit signal. And because this is just structured log data, you ship it to Loki from Lesson 11 and wire a Prometheus alert in Lesson 19. Anything over 5 denials per second per host pages you. Before you write a single profile of your own, know what Ubuntu already gives you. Out of the box, you get enforcing profiles for roughly 50 common services, Nginx, MySQL, bind deny, postfix, cups, and every snap is confined automatically, as we saw back in Lesson 2. But the gaps matter. SSHD and Postgres ship unconfined, and anything you build or apt install yourself is wide open until you run aa-genprof against it. The pragmatic habit is a weekly AA status sweep with alerts on any unconfined process facing the internet. Speaking of a status, here's the cheat sheet worth bookmarking. The commands you'll actually reach for week after week. Status and AI unconfined tell you where you stand. AA complain and AI enforce flip a profile between log only and blocking, with AI disable reserved for emergencies. After editing a profile, AppArmor parser R reloads just that one without touching the rest, and P lets you parse test before committing. When something breaks, journal CTO and AA logprof are how you answer the inevitable question, why was X denied? Now here's where AppArmor really earns its keep in 2026. Containers. The default Docker default profile is deliberately permissive. Fine for getting started, wrong for production. Real hardening means per container custom profiles layered with seccomp, user namespaces, and a read-only rootfs. That full runtime stack is a course in its own right, so we've packaged it as Container Hardening Mastery. 13 lessons covering everything from capability dropping and seccomp filters through destroless images, Falco and Kubernetes pod security standards. If today's lesson hooked you, that's the natural next step. Before we close out, the gotchas. 5 things that have bitten me or someone I trust in production. First, after an apt full upgrade, Nginx restarts but won't serve a thing. New binary, new paths, old profile still in enforce. Always grep journal TL for denied before you start guessing. Second, handwritten profiles where someone uses a single star instead of double star. Globs are not recursive, and logs vanish silently in enforce mode. Third, ARA disable is an emergency tool, not a debugging one. Use AKI to complain and alert on unconfined critical services. Fourth, a syntax error in one file aborts the entire reload, and system CIL will happily report OK. So always run AppArmor parser-p first, ideally in a pre-commit hook. And fifth, -- privileged on a Docker container nukes AppArmor entirely. Reach for capadd or a custom security op profile instead. So let's gather the 6 skills you've added in this lesson. You now understand AppArmor's architecture, an LSM hook doing path-based mandatory access control, the pragmatic counterpart to Selinex's type-based model. You can read a profile's anatomy, rules, capabilities, abstractions, permission letters. You've walked the safe rollout from complain into enforce, generated fresh profiles interactively with aa-genprof and aa-logprof, audited denials and journaled, and learned to tell a real attack from a buggy rule. And you know to hunt unconfined critical services before someone else does. Next lesson, unattended upgrades and live patch. Ubuntu's automatic patching story. And that's lesson 16, sandboxed. Architecture, profile anatomy, the complain to enforce workflow, and audit denials are all yours now. Next up, lesson 17 closes out stage 3 with Ubuntu's automatic patching story. Unattended upgrades, phased rollouts, and live patch kernel patching without a reboot, plus ESM for 10-year LTS coverage. Finish that one, and stage 3 operate begins. See you in 17.